middle of problem 7, just getting things all organized to be able to complete solving this equation. When you see a squared in it, you're going to have to, factor to answer. Okay? So we're all here but Samantha. So we found the least common denominator, and then when you multiply the numerator, then you can figure out what's left to write in the numerator, what cancels and what's left. 6 canceled, so x plus 4 times x plus 5 is left, and then the x plus 5 cancels, so we have the, looks like I missed this 6 up here, so that should be 12. I'll make it a 12 plus a 48. So that was a good thing. Review my work. There we go. Because only the x plus 5 disappears. Add that little correction to number 7. And it would have bit me sometime, so it's a good thing to find it out now, for sure. Okay, so we're going to get organized. It's 15x plus 75 minus x squared minus 9x minus 20. So I have to distribute that negative on all the terms. Now, since most of the terms are on the left, I'm going to go ahead and move, even though that's a negative, it is what it is. I'll do a little chess move to get rid of that negative at the end. So, let me see. So far, I've got a 15x minus a 9x. So I've got a negative x squared plus 6x, and then I combine 75 and 20, and I get positive 55. Equals the 12x plus 48. I'm going to move everything to the left side. So I have 0 on one side. In order to solve an equation, you have to have it equal to 0 before you can factor it. That's the solve quadratic equations. So I have a negative x squared minus 6x plus 7, and to I need a positive coefficient in front of my x squared so I can factor. I'm going to divide everything by negative 1. Nobody gets hurt. It's all good. Haven't broken any laws of the universe. I'm going to have to go to the next free page to finish out number 7 here. Okay. Number 7 continued. And this is day 3, period 5, for lesson 9.2, where we're solving rational equations. Okay, so if I divide all those by a negative 1, I get an x squared, then I get a plus 6x, and then I get a minus 7. And factors of 7 when subtracted give me 6, x plus 7, and x minus 1. And there is no extraneous solutions possible in this question because there's no place to put if they were extraneous. But if we didn't know, if there were no blanks to fill or whatever, I would just go back to my least common denominator, would happen to be that x plus 4 and x plus 5. These, neither one will make that 0. So that is at the end of number 7. So the way things go, yours model after mine. So questions. See patterns. Okay, last raw rational equation, and then we're going to put them in context. Where do these show up? This is 5 over x squared minus 3x plus 2 minus 1 over x minus 2 is x plus 6 over 3x minus 3. Factor, factor, factor. X minus 2 and x minus 1. X minus 2 and 3 times x minus 1. There we go. So we determine our least common denominator. Least denominator common. Least common denominator. The only constant factor is 3, so that's good. And then these two are made up of what my left one has already. So it's x minus 2 times x minus 1. So when I take that up there, see how those cancel? You know, when I bring this whole expression up on the numerator, x minus 2 and x minus 1 cancel, so I just have 5 times 3, which is 15. Okay. Over here, I'm subtracting, then the 3 is still there, and the x minus 2 cancels, so the x minus 1 is still there. Then over here, the x plus 6 will be multiplied by the 3 cancels, the x minus 1 cancels, so I'll just have an x minus 2. Like that. Okay, so we got a bunch of stuff. Looks like it's going to be another quadratic equation we need to solve for. We're not afraid. We're experts at that. So 15 minus 3x plus 3 is x squared plus 4x minus 12. So that's what you get. X squared minus 2x plus 6x minus 12. FOIL, FOIL, FOIL. 18 minus 3x is my left side. Then I can move the 18 by subtracting it. And then add 3x both sides. Because x squared is positive already over here, so I'll just leave it over here. So x squared plus 7x minus 30. So factors of 30 when subtracted give us 7. Right. Oh, it's plus 10 and minus 3. Thank you. Okay. Wrong yesterday, my friend. One of my top 5. We're just finishing up number 8. Did you have a pass? Did you check in?
Oh, I came late to school.
Oh, okay. But did you go through?
Yeah.
Okay, perfect. All right. The 2 answers, and again, number 8 has for no extraneous answers, but you can always check. Will negative 10 make this denominator 0? Nope. And will 3 make this denominator 0? Nope. So those are your 2 solutions. And that's where it crosses. If I put this equation into the Desmos as a function, that's where it would cross the x-axis, if you remember back when we were doing the graphing. Okay, now I'm going to leave. That's not going to work. I'm just going to leave this screen and read to you the story. But I'm recording it, so I have to stay on the screen. So don't write down this story, guys. Don't just listen to the story. Your story will be like my story, just maybe different numbers. So I will, the purpose for these stories were to let you know where these ideas are found in a real world application. So I don't do that enough. Algebra is very abstract, but that's always an important piece in learning algebra, is to realize where it exists outside of the textbook. Okay? So what I'm going to do is I'll read you my story, and then for this first story, it says you do not have to solve the equation. So that's kind of good. All you have to do is come up with the equation. And so that you're learning that piece of the puzzle. The solving's the easy part, right? It's writing that equation that's the challenge. Now here's where you can find a rational equation. If you happen to be a lacrosse player, you have a save percentage they keep on you. So they find the save percentage by dividing the number of saves you have by the number of shots you face. So the lacrosse goalie for this event saved 6, or so far this year, season, whatever, saved 6 out of 13 shots. So how many additional consecutive saves, and they use the variable S, must the goalie make to raise his save average to the new percent? So 6 out of 13 isn't 85%, you know, it's a little over half. So this is how you write an equation. The key word here is they're consecutive, okay? So he never misses any. So if he starts out with the 6 out of 13, then you just add his saves to the numerator and the denominator, because if he saved S saves out of S shots, right, then he would up his percent to 0.850. So that's all you have to do. Whatever ratio they give you in your work, then you just make sure you use the variable S. You write the new ratio, because that's the rational equation, right? Because it's got a variable in the denominator to equal the percent they give you. And percents are decimals, right? So this great example, wherever you want to get better at something, you could create a rational equation to determine how many you need to win to get your percentage better. Percentage. It's a huge thing in sports, huge thing in business, huge thing in medicine, huge thing in industry. It's all, you know, very valuable information to check your productivity, you know, so it's everywhere. So you make that little note, just write the little note what the equation should look like, okay? No objections? Okay, this is another rational equation, which is a little twist. It's a work problem. You guys have done work problems. They're a challenge. They're a challenge. They're a challenge for me. But once I understand what they want, then it's a little easier. Jake can mulch a garden in 35 minutes. So one garden, 35 minutes. That's his rate. Okay? Get one job done in 35 minutes. Rates, ratios. Together, Jake and Ross can mulch the same garden in 13 minutes. So if you take Jake's rate and add it to Ross's rate, it should equal the combined rate of one job in 13 minutes. So we got to figure out how long it takes Ross alone. So write the equation in the form where you take Jake's rate times minutes worked plus Ross's rate times minutes worked equal 1. So that, yeah, you're not any closer than I was when I first read this problem. The minutes worked is the minutes worked together. And I'll show you how I figured that out. Okay, rates are ratios. So one job in 35 minutes is Jake. One job in T minutes is Ross, and together they get one job done in 11 minutes. But this isn't the form they wanted in. They wanted this 11 multiplied to each ratio. So therefore, it would equal to 1 right here, see? So in your software, your equation would be whatever Jake does alone as a fraction, and then out to the side, you'd put the rate they work together, or the time that it takes for them to get it done together. And then Ross's, which is unknown, you got to use the variable t, I believe. Yep, they have it up in here. Where is it? Right there. Use t times 11 minutes is what they take to work together equals 1 job. So that's what you type in for your equation. So you got your numbers, right? So just jot down my numbers and don't forget to change it to your numbers. And yeah, that's kind of a common situation. It should take 2 people less time. And it's like, how could you add them together and get less time? You're adding fractions. That's what makes things less fractions. But I thought, how did they get that? What? I didn't get it. How could I get that equal to 1? Oh yeah, you just multiply the job time together to all the fractions, and you didn't break any laws. But they do want it separate like that, okay? Don't put the 11 as the numerator. All right? Kind of picky. But they're, special problem. Take special thoughts. Kind of fun. So there's another example of rational equations. Pretty pervasive in our society. It's important to know how to set these ideas up. All right, now 11 is, you got to come up with numbers. And so, sometimes if they give you all the numbers, you can kind of skip writing the equation. You can just make the numbers work with you to get the answer, okay? And this is one of those. They didn't ask you for the equation. All they asked you for is if you have a new skating rink that's rectangular and an area of 14,536. So here's my ice skating rink. And length times width is 14,536. Using an equation for the perimeter P of the skating rinks in terms of its width W, what are the dimensions if the perimeter, so they gave us the perimeter to be 500 feet. So that's square feet, that's feet, so we don't have to worry about the labels. Okay, here's the dirty little secret. Perimeter is just the length plus the width doubled, right? Length plus width plus length plus width. So if I divide it by 2, I get length plus width is 250. So I can just look up the factors of 14,536 using technology and see which ones add up to 250. Okay? So that's what you're going to do for you. So you're going to look for, and so it's it's a little quadratic, but we don't have to have a rational equation to solve this problem. And you see why I had to divide it by 2, because I want to know what they just add up to half of the perimeter, okay? So you just have to peruse through the list. There's lists online and find which 2 they are. So I'm going to get my pad. Since my computer screen's taken, I just look up factors. F-A-C-T-O-R-S. That's my number. 14536. Let's see, I don't know if it's gonna show up. There it is. And they're listed there. So kind of want to go in the middle. You can't see it. The screen is shiny, too shiny. Ah, pickles. Calm down. There we go. Okay, I am looking here. I say 250, 92, and 158. Looks like it is. I'm not zoomed in very good on that now. Okay. See if it shows up better. Don't need the advertising. Okay. 92 and 158 add up to 250. Right on there, up here at the top. Okay, you got your screens. So 92 times 158 is my 14,536, and 92 plus 158 is my 250. So then up here, I think they list the length first. So 158 by 92. Okay. What they wanted you to do was rewrite these just with W. So then you'd have a rational expression. Since 14,536 is length times width, then W, length is 14,536 divided by W. That's where the rational expression would come in, but you don't have to do that. So, which is nice. We would have just put it here and then solve for W. But this works just as well. And that's, what you're going to do in the real world. If you must, just spend your day writing algebra questions. But if you need an answer, you can, and understand how perimeter and areas are related. There's no sense in writing equations. All right, 2 more. Okay, 12, we're back to a story that you only need the equation for, and you've probably got the hint on how you do this now. Water flowing through both a small pipe and a large pipe can fill a tank in 9 hours. Water flowing through the large pipe alone can fill the tank in 20 hours. Enter an equation that can be used to find the amount of time T in hours it would take to fill the tank using only the small pipe. So we've got the large pipe's rate, and together they can do it in 9, plus the small pipe's rate, and together they can do it to 9. They will fill the tank. Okay, you got your numbers? Type in carefully. Make the number that they do both in off to the side as multipliers. And yay, you didn't have to find that answer, but 13 you do. Start at the top of the page for number 13. It's a doozy. Those were rather simple applications. 13, there's no shortcuts. They just got to do it. I don't think you can even guess and check because it's like not even a whole number. So if you're ready, number 13, we're going up the river. A riverboat travels at the average of 14 kilometers per hour in still water. The riverboat travels 110 kilometers east up the Ohio River and 110 kilometers west down the Ohio River in a total of 16 and a half hours. To the nearest tenth of a kilometer per hour, what is the speed of the current of the river? Boy, doesn't that sound like a nightmare. Now, we all know distance equals rate times time, right? And so we've got two ways and a combined time. So I am going to use the version of this formula. Time is distance divided by rate. So when I add the two, distance over rates, I'll get the combined time. So that's what I'm doing, why I'm doing it. So what am I going to do? I can call the current. I need the current. They didn't give me a variable to put in the current because all they wanted me to do is solve the problem. So I'll call the current C. So as you go up a river, the current is against you. So you're going to go slower. So up the river is 110. That's your distance. And without a current, it's 14. And it's going to bring you down. How fast the current is going to make you go slower. Then you go down the river 110 with the current, so it's going to make you go faster. And then distance over rate plus distance over rate is equals the combined time, which was 16.5 hours. So that's where I got my equation. And, you know, nobody can put in a number there and guess it right. You know what I mean? We got to do the algebra. So LCD is each one of these. That's over 1. Oh, pickles. My brain's making up numbers. That's my LCD. So if I multiply my first fraction, the 14 minus C cancels, so I have 110 times 14 plus C. My next fraction, the 14 plus C cancels, so I have 110 times 14 minus C. And then they both get multiplied over here because there's no denominator to be canceled. So it's 16.5 times 14 plus minus C, whichever one I want to write first, 14 plus C. Okay, there we go. They're all in one screen there, and then the rest is just algebra. I'll zoom it out a little. So dig into you're going to do the distribution. Multiply. So I snitched this off the desk. I borrowed out my calculator to a student. 1540 plus 110C plus 1540 minus 110C equals, I have to do these two first. 16.5 times 196 minus C squared. So 1540 doubled. Give me 3080. 110 minus 110C disappears. So I have 3080 equals, then I get to distribute 16.5 times 196. 3234 minus 16.5C squared. And since there's only a C squared, there's no C, I can just get C squared alone and take the square root. So I take away 3234. I get a negative 154 is a negative 16 and 5/10 C squared. So we get a divide by negative 16.5, and I get a pretty ugly, well, it's not bad, 9.3. You don't want to round, guys. You don't want to round here. You want to hit square root, second square root, second answer. Okay, so see what I got right now? See that? I'm going to put second square root, second answer. That's at the bottom here. And then I get my decimal I get around. Now I round. So 3.05505, etc. See, if I rounded early, I might not have gotten an accurate decimal. So mine is 3.05505, etc. And it says up here, round to the nearest tenth. So it's 3.1 miles per hour. That is my last problem. So it's your diligent duty to enjoy these experiences with rational equations. When you come back from your break, we will review and assess. Got 5 days to get this stuff right, all right?